Chapter 10.4, Making Predictions from Data. So what is the entire point of probability? The entire point of probability is to be able to predict something, okay? Looking at data that you have, looking at past performances, I can predict something that is going to happen in the future. So vocab for today is population, which is a group about which you want information. Sample is part of the population. So to predict the number of times an event will occur, I'm going to multiply the probability of that event times the total number of trials in order to find the predicted number of successes. Now, this is not a guarantee, this is predicted, okay? Statistically speaking, using probability, the actual number should be close to this number, but it is not a guarantee. This is a prediction. So let's take a look at example 1. For a family with 2 children, suppose there is a 25% chance that both children are boys. Out of 72 families with 2 children, how many are likely to have 2 boys? So the probability of an event. So probability of 2 boys equals 25% or 1/4. Okay, the total number of trials, in this instance, trials is going to become number of families. Okay, so I have 1/4. Oh, well, I have 72 families. So number of trials or families, 72. So using this formula, 1/4 times 72 equals 18. So approximately 18 families, so 18 families, or about 18 families, will have 2 boys. All right, now again, it's not a guarantee, but, and you can even change, instead of saying will have, you can say are likely to have 2 boys. Using this word likely is a little bit better when we're talking about probability than will have. That's more of a guarantee, and this isn't a guarantee, it's just a likeliness. All right, example 2. So a company makes 15,000 toy robots. The company inspects 200 robots at random. The sample, which is that 200 robots, has 5 faulty robots. Predict how many of the 15,000 robots are likely to be faulty. So I'm going to set up a proportion. On one side, I'm going to have the sample, and on the other, I'm going to have the total population. So in my sample, I had 5 faulty robots out of 200. Now notice that the total is always the denominator. My total population of robots is 15,000 robots. I want to know statistically how many of those are faulty. So to solve a proportion, I'm going to cross multiply. So 200x equals 15 times 15,000 times 5 is 75,000. Divide both sides by 200. And x equals 375. So 375 robots are likely to be faulty. Okay, so that's it for the 2 examples today. Please complete your quick checks and your CYU. And if you have questions, I will answer them the next time I see you.